Alright, good evening. My name is John Maloney. This is the week 3 assignment for Introduction to Basic Ammunition and Ballistics. So, going over part 1, which is the answer of what is an explosive versus what is a propellant. To understand that, really, you have to understand what the major difference is between the two of them. So, the major difference between them is how fast the entire reaction happens. You have an explosive which was made to happen in an instant, and then propellant is made to prolong its reaction in order to, for lack of a better term, push whatever it is that it is fueling. So the Introduction to Basic Ammunition and Ballistics, SDI textbook states that a reaction that propagates faster than the average speed of sound, which is 1125 feet per second, or supersonic, is known as detonation, and that would be an explosive. A reaction wave that propagates slower than the speed of sound, or is subsonic, is known as deflagration. And in this instance, we're talking about propellants, and propellants are the ones that we want to cause the deflagration. So modern propellants are intended to push the projectile or whatever it is that they're fueling, and as stated previously, an explosive is meant to detonate in an instant and cause a massive reaction. Moving on to part 2, which is the question: should the industry move away from current propellants, and if I believe so, what could possibly be used instead? Well, currently, according to the National Academics, or nationalacademies.org, there is a research paper on advanced propellant research. Right now, currently, the Army is looking to use ARL and RDEC, which are energetic formulations based on thermoplastic elastomers, and these formulations include the new high energy filters such as like CL-20, and different like nanostructured materials, and a lot of this research is based off of nanotechnology and improving. So using these, they've made a 20% increase in energy without actually increasing barrel wear on the firearms that they've been using this stuff on. I think that it is a good idea to possibly stray away from some of the propellants that we've been using currently, because we can improve on them with modern technology, ergo the nanotechnology, or even environmentally, we can try and save what we can of the environment by changing up the chemical composition of the propellants. By changing up the chemical composition of the propellants, we could possibly reduce the amount of footprint that the firearms industry has on the environment. One example would be, let me take a look, see here. So one example would be, there is it's a U.S. company that is doing performance characteristics that are similar to current propellants, which are like nitrocellulose, nitroglycerin, but it is called the excuse me, this is French, the Propulsor de Point of Poudre. So they call it PAP 7993. It's a solid propellant. It's very similar to like the M1 propellant. However, it is an environmentally acceptable plasticizer to replace DNT. It doesn't increase the performance of the propellant at all from their research, but it does have a more environmentally friendly impact. Moving on to part 3, let me switch this camera around